طيب, just as summary, we'll say what is the meaning of the entropy as a summary. When we said there is entropy, we said the entropy of the system, which is S, is the entropy of the system. This is a measure of how the system is random. So if the system is very random, or the substance inside it is dispersed, it's not well arranged, so it's very random, every part in a different place, then there is a high entropy for the system. But if the system is organized, like for example, if we compare the gas to the solid particles are very well organized, they are not random, which means that they have low entropy. They have low entropy versus the gas. So gas has high entropy while the solid has low entropy, because it's this one is organized, it's not random. So this is the definition of entropy. Zero entropy happens when the system is at 0 Kelvin, and we have known from grade 10 that 0 Kelvin, this is an imaginary degree. This is 0 Kelvin. This is an imaginary degree in which the system reaches a temperature of almost minus 273 degrees centigrade. And this is not practically found, but we'll say that it is very well organized. So we call this the solid crystal. The system is perfectly organized. So we'll not find this in the reality, but we'll know that this is the best or the most organized system, and it will be equal to zero, and it will be equal to zero entropy. So equal to zero entropy means that the system, it's not at all random, but it is very well organized. Type. And I have something called the standard entropy change. What is the standard entropy change? The same way we used to know the standard enthalpy change, when the enthalpy changes from one system to another, I can say also the standard entropy change, which means that the system, that which is delta S, it will show me how the system changes from one state of entropy into another state. So, for example, after the end of a chemical reaction, after the end of the chemical reaction, I have here reactants changed into products. This reactants has a certain entropy, and these products have a certain entropy. So what happened? Did the reactants has higher entropy than the products, or the products has higher? So what will happen? It's going to decrease or increase. This is what we will call the delta S, or the change in the entropy. And we always know that this is the symbol of standard, which means that I will check this only at standard conditions, at fixed conditions, which means that anybody who is making this reaction will be always following the same standard conditions. If you want to calculate what is the delta S, you need to see what is the delta S. You need to see what is the sum of the entropy of the products minus the sum of the symbol. This symbol means the sum of, and this symbol, the sum of entropy of the products minus the sum of the entropy of the reactants. So for example, if your entropy was 100 and it becomes 300, then the entropy change is equal to 300 minus 100, so it's equal to 200. This is the value of the change in the entropy. It was كانت كذا وبقت كذا. So I can say that it can be a negative, the delta S can be negative entropy, and the delta S can be positive. So if it is negative, it means that we have decreased it. We have lost some entropy, so the entropy has decreased. And if it increased, means the entropy becomes positive value. So if you find it as a positive value, means the entropy was small and then get bigger in the products. And if it decreased, means it's negative, means it was big and then decrease. The same way we used to say delta H is negative and positive. When we said negative, means it's decreasing due to the loss of heat or loss of enthalpy. And when we said it's positive, means that it has increased due to the endothermic reaction, for example, which added some heat or enthalpy to us. So same as delta H is negative and positive. Negative is decreasing and positive is increasing. And if you want to have an example for it, we can discuss the reaction between calcium carbonate and its breakdown or decomposition into calcium oxide and carbon dioxide. What is calcium carbonate, mister? This is a solid. And what is calcium oxide? This is a solid. And what is carbon dioxide? It's a solid. It's a gas. So let's try to imagine what happens to entropy here. The calcium carbonate was solid. What did we say about the solid? It is organized. It is having a low entropy. What about the gas? It changed from solid to gas, which means it changed from an organized into a random system. So it changed from the organized to random, which means that it changed from a low entropy into a high entropy. So this one has low entropy because it is organized solid, because it is solid, and this one is high entropy because it is disorganized or it is random. So you want to say that you had at the beginning small number and it become a bigger number. So this means that it increased while it decreased. It means that entropy has increased. And we said that increase means positive entropy. So the entropy, when it rises, it means it is a positive number. So this means that you have delta S is positive entropy. So the matter changed from solid into gas. This means that the entropy has changed, and this is a delta S positive reaction. What about if I change it, for example, from lead to plus? This is an aqueous solution of lead ions, means I have a beaker here and it has lead ions dispersed in the solution. And when it reacted with carbonate ions, so it has some carbonate ions here. When they react together, what they form, Mr. It's also aqueous here. It has formed lead carbonate. What about lead carbonate? Is it dispersed? No, I will see that lead carbonate settles here at the end, which means precipitated. So it is precipitated at the end. So is this organized or this is organized? Mister, this is dispersed everywhere in the system. Dispersed everywhere in the system, which means it is random. But these particles are sitting here organized like crystals of the precipitate. So they are less organized. They are more organized. They are more organized. So what happened to the entropy here? This one is random, which means it has high randomness, which means that it has, yes, Mumtaz. So this is high randomness into low randomness or an organized structure, which means that our delta S is negative. Why? Because it has decreased. So whenever I see something changes from the ions to the solid precipitate, it means that the delta S is decreased. And don't forget that the opposite is the vice versa. So the opposite is the vice versa, the same like in delta H. So in the delta H, if you have a reaction which is forward endothermic, and you ask it about the backward one, it will be exo. Here it is the same. So same as delta H. If the reaction is delta S is forward, is positive, then this means that the backward is going to be a negative delta S. It will be negative delta S. Because when you change from the organized structure into disorganized or dispersed, means you have increased its entropy, means the delta S is going to be positive this time. So it is the reverse of the other one. Here also, if you change it from the gas into the solid, means you become more organized, means that the delta S has changed, means it becomes negative. So again, if the reaction forward is something, the backward is the opposite of it, the same way we spoke about the delta H. Well, let's see another example. If I have C2H4 plus oxygen, so if I have a reaction, for example, between C2H4, which is a gas, and this gas has reacted with oxygen, so it is burned. This is an ethene, so plus O2, and it has burned to form carbon dioxide. Any hydrocarbon which will burn will make carbon dioxide and water. Both of them are gases. So this is a gas. This is a gas. Has changed into a gas, and this is a gas, and this is a gas. For the balance, we'll see that this is 2 plus 2 plus 2 plus 2. So 2 and 2 and 2. Mister, if I just compare the physical states, it will be a little bit hard to compare them. But in order to compare correctly, it's better to try to check the number of the moles. Why is that? Because if you have more number of moles, this means that you are more random or more disorganized. The same way if I asked you if you have one book on your table, while if you have 10 books, if you have 10 books, then the chance that you get disorganized is more. This is because where is this book is going to happen to come here or here or here or here, and that's it. But if you have more particles, then you have many instances or many chances that this will be random. So if you increase the number of moles, then you are increasing the possibilities of randomness. So you are decreasing or increasing entropy. You are increasing the entropy. You are increasing randomness. While if you have less moles, then you are decreasing the entropy. So let's calculate. On the left side, there is 3 moles, and on the right side, there is 4 moles. So what happened? You increase the number of moles. So increase the number of moles. This means that you have increased the entropy. This means that the delta S in this case is positive, right? Because you have increased the entropy because you increased the number of particles. And again, the opposite will be decreasing the number of moles, means that the delta S is negative because you decrease the chances of being random. If I tell you where this book would be, this is one case, this is the second, third, 4, 5, 6, 7, 8, 9 or 10 possibilities. But how many possibilities or probability you can have for randomness of many randomness? This one can be here, and this one is here, and this one is here, and this one is here. So I can make a lot of random cases. So the number of moles increasing causes the randomness to increase and the delta S to increase. Okay, the next thing, this is the idea of what is the delta S and what is S, what is the entropy and what's the increase in the entropy. The second idea that we need to discuss is the Gibbs free energy. Gibbs free energy. And Gibbs free energy is what we know as the free energy, or G, sometimes known as the free energy, or G. This is a value which is given so that I can determine if the reaction is favorable, it's going to happen by itself, or unfavorable, but in respect of thermodynamically. What is the meaning of these big words? It means simply that is the reaction is spontaneous or non-spontaneous. So we know that spontaneous means that the reaction is going to happen by itself. The reaction is going to happen by itself. Like the same way I put a ball on the top of this mountain, I know that spontaneously this ball is going to go down the hill here, but there is no chance that is going to go up by itself. So this is a non-spontaneous. This is a non-spontaneous probability, while this is spontaneous. This is going to happen by itself, but this is not going to go up until I come and push it, or anything, wind or whatever pushes it up. So if the reaction is thermodynamically favorable, means it is spontaneous. If it is thermodynamically, and thermodynamically means related to the amount of energy lost or gained. So before in the exams, they are saying spontaneous and non-spontaneous. Now they will be saying favorable or unfavorable. And this is very important in the exam. They can say favorable or unfavorable thermodynamically. Okay, so what can I say about the change in the G?
Mr. Wait, what's that thermodynamically?
Thermodynamically means if it is related to the heat, and thermodynamics means is it going to lose heat, is it going to gain heat? And actually it is a difficult idea just to know what is G without understanding that it is related to H. So I can talk about any equation, and to know if this is thermodynamically favorable or no, I have to check its G and I have to check its H. Because G is a little bit abstract idea, so we cannot know what is the meaning of it exactly until we link it to an equation. Mister, I want to know what is G. What does it mean, G? I know what is M. M is the mass. I know what is volume. I know what is H. H is the heat content. But what is G? This is the amount of free energy that's inside the substance or inside the reaction. We will understand more better if we try to know what is delta G. That's the change in free energy. What is the meaning of change in free energy, mister? It means does the delta G decrease or the delta G increase? It can be calculated from the standard free energy of formation. Do you remember when we calculated the delta H from the standard free enthalpies? Like we'll say it is the delta H is equal to the sum of delta of the H, or the delta H, the sum of heat content of products minus the sum of the delta of the H of the reactants minus the sum of heat content of the reactants. Like we have a reaction and we need to know what is the product. So we'll say this is CH4 and reacts with oxygen. So oxygen to give CO2 and H2O with the balance. So this is 1 oxygen, this is 4 oxygens, this is 4 hydrogens. So it is balanced like that. We used to know that what is this calculated like by subtracting the heat of the content of the products. So we'll add this one plus 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 this one. And say delta H. So sum of delta H of products minus sum of delta H of reactants. And then we calculate it. In the delta G, we'll do the same exactly. So we'll say delta G is equal to what? The heat content of the products minus the heat content or the free energy. Not the G is the free energy of the products So delta G of formation of the products and delta G of formation of the reactants. Mr. Where do I get the values for this one? The same he will give me, the same way he used to give me the delta H for formation of products or reactants in a table and tell me the C double bond O is equal to so and so, the HO is equal to so and so. He will give me also the values for the delta G. So, Mr. I just calculate delta G is products and delta G is equal to reactants. What you will get as a result, you will get a number. So you will get a number. How do you get the results? Again, just by getting them from the table. If there is a reaction happening like A and B form C and D, then I will say that I have 2 or 3 possibilities. The first possibility is that the delta G will come to equal to 0. If the delta G, which means the change in free energy in the reaction is equal to 0, this means that the reaction is in equilibrium. So it's not favored to the front or not favored to the backward. It's the same like I'm saying here. This one is favored going from up to down or down to up. This is favored from going to up to down. And it is unfavored. It's not good. It's non-spontaneous going up, but it is spontaneous going down. If I said that there is no up or down and both possibilities are equal, this means that delta G is at equilibrium. If I said it is delta G is equal to negative, so in this case, if it comes as a negative value, this means that this reaction is thermodynamically favored. Thermodynamically favored, or in the exam, he might also tell me this is a spontaneous reaction, which means that it's going to happen. So which reaction do you think will happen by itself without me interfering? Do you remember when we used to say in chemistry, this AG reacts with the, or CU reacts with AG to form the opposite because CU is more active, reacts with the AG plus to form what this is going to kick this one from the compound to form Cu2 plus and Ag. We used to say this reaction is spontaneous. What does it mean spontaneous? Yani it is going to happen, yeah, mister. It's going to happen. Why? Because copper is more reactive than silver, so it's going to kick it out. So we used to say this reaction is spontaneous, but the opposite is not spontaneous. If you try to reverse it, it will not be spontaneous. Why it's not spontaneous? Because the opposite is not going to happen. Why it's not going to happen when you put the opposite reaction? Because copper is less reactive than silver is less reactive than copper, so it's will not be able to react together. It's not going to kick it out. So we used to say that this reaction is non-spontaneous. So there is a direction which we will say that the reaction is spontaneous. It can happen. What is that? In this reaction, if you calculated delta G, you will find that it is negative value. So delta G will be negative value. لو حسبت delta G, how I'm going to calculate it? By the numbers. He will give me the numbers the same way here. If I calculate it and it's negative, then it is spontaneous. If I calculated the delta G and it is positive, this means that the reaction is Non-spontaneous. What's the meaning of non-spontaneous? It's not going to happen. It will not happen. But this also means that the opposite is going to happen. So if I tell you that the forward is spontaneous, what does this mean about the backward? It's non-spontaneous. What if I told you the forward is non-spontaneous? So what is the backward? Spontaneous. So it's the opposite of it. If this is going to happen, then the backward is not going to happen. Why it's happening or not happening? For different reasons. It depends on this reaction. Is this a redox reaction? It's a precipitation. So it depends on many reasons. But how can we calculate it mathematically? By the value of what? Delta G. If delta G is positive, what does this mean? The reaction is thermodynamically what?
Non-spontaneous.
Non-spontaneous. So it is non-favored and non-spontaneous reaction. It's not going to happen. What is, if it is zero, means the reaction is in equilibrium. What does it mean in equilibrium? It means that there is no direction favored over the other. There is no direction.
In the exam, how will I know that it's zero or negative or positive?
He will give me two types of equations. The first equation or reaction or examples, he will ask me to find delta G. So he will give me a reaction in which he tells me this is the delta G, find it out. And I will give you now the equations to find this out. And in some reactions, he will give me the delta G and ask me to find something else. I will give you now a couple of reactions in which delta G is related to other points. Do you remember we are finding delta H by numerous ways? Like delta H is equal to what? Is equal to Q over N. And this is negative MC delta T over N. And delta H is equal to also sum of the heat of formation of products minus reactants. So there are many ways that I can get the delta H. Also, there is multiple equations that I can use to find the delta G from. And how do I choose? It depends on my given. So it depends on my given. Okay, until now we just took one of them. Delta G is equal to delta G of products minus delta G of formation of the reactants. But how can I link them together? So how can I put them all together in single equations? What are they? The delta H, the delta G, and the delta S. This is the change in enthalpy. This is the change in free energy. This is the change in entropy. How can I link them? I know that these things are too difficult to understand. That's why usually I will just get the values using the equations, because this is very abstract ideas. So I need just before knowing how they are linked together to agree about this idea. The reaction will happen if the delta G is negative. If the delta G is negative, it is spontaneous. This is what is the most important thing. If the reaction is delta G negative, then it's going to happen. Otherwise, it's not going to happen. Okay? So this means, Mr. In nature, I usually try to tend to form towards high dispersion and low energy. High dispersion and no low energy. يعني Mr. يعني usually in my system to happen, every reaction tries to decrease the energy. Why it tries to decrease the energy? Because decreasing energy means that the system is stable. We know that if you have high potential energy, for example, you are unstable. So decreasing energy makes the system stable. And also it tends to be directed towards high randomness, to increase randomness. So increase in S. There is a saying which says that the system or the universe also tends to go towards randomness. The same way we said you have your room, and your room usually tends to change from organized. By the end of the day, you will find it unorganized, but never the opposite. You never go and leave your room or unorganized, and then at the end of the day come to find that it became organized by itself. But the chance that it's going to be unorganized automatically. It's not only your room, but the whole universe like that. It tends towards what? To move towards what? Randomness. to move towards randomness. This means that the S is usually increasing. The S is usually increasing. So in any system or any reaction, the system tries to tend usually to increase the randomness. Why? Because the whole universe tends to do that and decrease the energy because this makes it more stable. Okay, Mr. Just cut to the point. What is the most important thing to say that links the delta G and delta H and delta S? It says that delta G, which is the change in the free energy, the of course, the delta G has to be, what do you say? Delta G, which is, let me put everyone in. Standard change in free energy, always has to be standard conditions, is equal to delta H, Mr. Also in standard conditions, minus delta S multiplied by T. This is the equation to memorize. What does it tell me? If you want to calculate the delta G of the system, just subtract the delta H of the system minus the delta S multiplied by the T. What is T? It is the temperature that you are asking in. The temperature in Kelvin. So this is the temperature in Kelvin. So how do I know that, Mr.? He will give me the values. Either he give me this one and give me this one unknown, or give me this one and this one and this one and asks for delta G. So I will use this in most of the equations. And if you notice, this is the second one. So that was the first law. That we used. What was that? Delta G is equal to G of products minus sum of G of reactants. And this is law number 2, which tells me how do you get it? It's equal to delta H, the change in the enthalpy change, minus T multiplied by the change in entropy. Again, the values will be given, and there is only one unknown. It's just to put the numbers and find the unknown one. So what is T? We said that this is the temperature in Kelvin. So this is the temperature in Kelvin. Okay, the most important thing which makes the students make mistakes in this is the units. Usually it is very easy to substitute because delta G is given, delta H is given, delta S is given, asks for T or whatever is, there is usually one unknown and you can find it directly. But usually the mistakes come from the units. The delta H, we know the unit for it is in kilojoule or joule per mole, in joule per mole. So this is the, kilojoule per mole. This is capital. So kilojoule in mole, this is small and this is capital. While delta S is usually in joule per mole, and there is also the degree in Kelvin. So delta S is in joule per mole per Kelvin. So this is the most dangerous part in which all the people make the mistake and get totally different numbers from the required ones. Once we start to answer the questions, we'll find the things get a little bit easy to understand. So don't forget to convert the values from delta G, from the kilojoule into joule. Of course, here by multiplying by 1000 to change it into joule. And if you are looking for the delta H, don't forget to divide by 1000. Again, this is the only point in which the students make the mistakes, and the other points is very easy to just substitute. Okay, so just make sure that they are both the same. It's not necessary what you get, as long as, so it's not necessary you get it in joule or kilojoule. Just make sure they are both the same. Just make sure if you are using joule here, then use joule here. If you are using kilojoule here, use kilojoule here. So it doesn't matter which one you use, unless he asked you, of course. If he asked get it in kilojoule, then you have to get it in kilojoule. But if he didn't ask, it's okay to use this one or this one. Just make sure that you are using the same here in the equation. Type. So let's see some examples. So this is CO reacts with H2O and forms carbon dioxide and hydrogen. He said that the delta H of the reaction is equal to minus 41.2 kilojoule per mole. Means when this reaction happened, it was an exothermic reaction. It is an exothermic reaction. And because this is an exothermic reaction, there is heat loss. For every mole, 41.2 kilojoule was released. And he gave me also the delta S. He said that the reaction become more random. How did you know that the reaction become more random or less random? Mr. The entropy has decreased. So this does not mean more random. It means less random. Can you explain what? So this is less random because entropy decreased. Mr. That was gas, and this is gas and gas. How many moles here? There is 2 moles. And how many moles here? There is 2 moles. So it's difficult to explain this one here related to the number of moles. That's why it's very important to get the delta S. In some cases, you cannot explain just by gases or liquids or solids into liquids or number of moles. In this case, you have to depend on what? On the value that he has given you. Tell you, Mr. And what is the temperature here? He said the temperature is the temperature, but take care, this is temperature in what? In Celsius. So temperature is equal to 25 degrees centigrade. And he is asking if the reaction thermodynamically favorable or no. So what does this mean? We need to find out what? The delta G. If you found out delta G and it is negative, so this means that that reaction is thermodynamically favorable if it's negative. But if it is positive, then this means that the reaction is thermodynamically unfavorable. Don't forget. So negative means favorable, positive means unfavorable. Okay, Mr. So I'll put the same equation here to use it. Delta G is equal to delta H. Okay, so let's use the numbers. Delta H, what is delta H? Is negative 41.2 minus what? Temperature. What is the temperature, Mr.? We said that temperature is equal to 25, but don't forget 25 has to be changed. So it is 298 Kelvin multiplied by what? Delta S. And what is delta S? Negative 135. Don't forget what we agreed about. What did we agree about? Both of them has to be what? In the same units. Both of them has to be in the same units. So you have to divide this 135. This is joule. You want to change it into kilojoule. So divided by 1000. So this will be negative 0.135. Negative 0.135. Now it has changed it also into kilojoule. So now this is in kilojoule and this is in kilojoule. Otherwise, you cannot be in different units. Don't forget the negative charge because this is very important. Otherwise, it will change the value for you. By calculation, just subtract this one from these two. You will get delta G is equal to negative 0.97 kilojoule per mole. And this is the delta G. Mr. We said that this is negative. So is the reaction favored at 25 degrees? Yes, it's favored at 25 degrees. How did you know it's favored? Because it is negative value. Because it is as negative delta G. So it is negative delta G, so it is favored. That's it. That's all what we need to know. To do is put the delta G equal to delta H minus T multiplied by delta S. Okay, then you found that it is equal to negative 0.9. The second question is asking me, at what temperature would the reaction be no longer thermodynamically favored? Okay, you told me that it is at 25, it will happen. But I'm a little bit greedy. I want to know. So there is a point at which the reaction is at equilibrium, right? No. There is a reaction at which it is at equilibrium. And there is a point at which it is favored. And there is a point which is unfavorable, right? Now he is asking me at which temperature then it will be unfavorable. At which temperature it will be unfavorable. Mr. How can I solve this one? I will use the same equation. I will use the same equation again. So this is the reaction. And this is the same equation. What was the equation? Can you remind me what is the equation? Delta G is equal to delta H minus T.
I can't find this question in the course revision.
This is not the course revision. This is just a general revision for all the rules.
Oh, okay.
Okay, so delta G is equal to delta H minus T delta S. Okay, Mister, what do you have here? I have the delta H. What was the delta H? Negative 41.2. And what's T? I don't know the T, Mister. I don't know what is T because he asked me. This one, I'll just copy this one. I don't want this part. So what is temperature? He's asking me at which temperature. So temperature is unknown. And what's delta S, semester? Again, negative 0.135. Don't forget, this is divided by 1000, right? To change it into kilojoule. Mister, but what will be delta G? What will be delta G? I need to find which point. I need to find which point? This point. Why, Mister? Why you are looking for this point? Because anything after it or before it will be favorable and unfavorable. If you find the temperature at which it is favorable or unfavorable, you will know when above what it is good or above what is bad. Let me explain it in a different way. There is a temperature at which there is equilibrium. It's neither favorable and neither unfavorable. And there is a temperature at which it is favorable. If you move from this temperature to here at 25, it was favorable or no? It was favored, right? So let me find the temperature under which it is unfavorable. So this means I need to find a certain temperature here. Below this temperature, it will be unfavored. Above it, it will be favored, including 25. What is this temperature? Is it what we will look for? But what is delta G? What is delta G? Can you try to know what is delta G? Delta G here will be equal what? What is the point we are looking for? What is the point we are looking for? Delta G is equal to what? 0. Why, Mister? Because before it and after it, there is change. So it's like I'm telling you, what is the temperature? What is, for example, I have gained a lot of weight in Ramadan. So I'm telling myself, this is the point that I am happy at it. Above this weight, I will be unhappy because I'm what? I'm very fat. And below this one, I will be happy because I am what? I am not fat. So I'm asking you, what is the temperature or what is the weight that you are happy at? You are not happy or unhappy, that you are at what? Equilibrium. I'm neither happy or not happy. So you told me I'll find it out as 70. Then I told you, احنا من شوية طلعنا ايه مثلا 65. Are you happy now? Yes. So I'm telling you that anything below 70 is what? Is favored. And anything above it is unfavorable. I don't like it like that. So in the previous question, what did I tell you? I tell you I have 65. It's favored or no? You told me it's favored. How did you know? Because it's the delta G is equal to what? But in this one, I'm asking you, at what temperature would the reaction be unfavorable? So you have to find what? The point of what? Equilibrium. The point at which you are moving between these two. How to find it? At the point of equilibrium, delta G is equal to what? Memorize this one. At the point of equilibrium, delta G is equal to what? 0. What if it goes beyond 0? Delta G is 0. At what? Equilibrium. What it becomes negative? What if it becomes negative? It becomes negative. أول ما تبقى negative تبقى إيه? Favored or unfavored? What if it becomes negative? If delta G is negative, then it is what?
It's favored.
Favored. If it becomes positive, then it is unfavored. So I'm asking you to find the perfect temperature at which there is move. So what to say here? Then put instead of delta G what? 0. Again, this question will come a lot, and you will find it also in the course revision in a similar question. What is the temperature at which you are moving between favored and unfavored? You are not favored or unfavored. You are 0. So you have to put delta G is what? 0. So if you calculate it here, you will get temperature is equal to 305 Kelvin. So this means, Mr. 300 at 300 at 5, at 300 at 5, you are at this point. You are neither favorable or non-favorable. This is the delta G is equal to 0. How did you find it out? I have this one, I have this one, I have this one, I found this one. So delta G is 0. Anything of a temperature, let's change this into Celsius. What will be this in Celsius? Subtract minus 273. So 305 minus 273 is, 305 minus 273 is equal to 32. Mister, this means what? That at the temperature 32 degrees centigrade, you are at what? Equilibrium. Anything which is less than that will be good. How did you know, mister? Because you said 25 is favorable. So anything less than 25 will be okay. The reaction will happen. But anything more than 32? More than 32? Then the reaction is unfavored. Oh, so the reaction was asked, the first part A was telling you, I am 25. I am favored or no? Then you looked for delta G. But in part B, he asked you, what is the temperature in the middle between favored and unfavored? How do I get it usually? Always put it the same way. Delta G is equal to delta H minus T delta S. Okay? And what you will put for G? 0. Then you find the temperature. He will ask you always, what is the temperature in which you are in between favored and unfavored? But mister, how do I know which direction is favored? How do I know that less than 32 is better or 32 is more than 32 is not good? Because you told me here is 25 is good. Do you remember? You told me 25 is what? When we calculated 25, it turned out to be good or not good, favored or not favored? Favored. So this means that anything less than 32, including 25, is favored. But anything more than that will be unfavored. So he is asking me, what temperature would the reaction no longer be thermodynamically favored? I will tell him anything more than 32 degrees centigrade or 305 Kelvin. This question will come a lot. This question will come a lot in the exam. It's one of the most favored questions for the examiners to bring about entropy. They like this one very much because they need to know the student understand what is the meaning of equilibrium and delta G is equal to 0 or not. Okay, one more point that I have to memorize as it is. One more point that he always asks me about, and I have to memorize it as it is. لازم أحفظه. I have to memorize this point. What does it say? It tells me I have a combination of status for the reaction. If the delta H is negative and the delta S is positive, I will know that this reaction will always be favored because delta G is negative always. How do you know, mister? Even if at low temperature or high temperature, I calculated. You told me delta G is equal to delta H minus T delta S. جبت شوية أرقام. I started putting some numbers and trying. I found that if this one is negative and this one is positive, so no matter what I will do, the delta G will always be negative. So, sorry, now I have a reaction in which delta H is negative and delta S is positive, this reaction will always happen. It's always going to happen. What do I do with this one? You have to memorize this table. But what if it is positive delta H, يعني reaction endothermic? So the reaction is exo, and here there is increase in entropy. لكن الرياكشن لما يكون endothermic when there is decrease in entropy, this reaction will never happen. Will never happen. How did you know that? Because whatever you do, the delta G will come as positive. برضو أعمل إيه يا مستر? I have to memorize these 4 cases. طب يا مستر إيه الأذر case? I have third case tells me the delta H is positive, which means that it is endo, and the delta S is positive, which means that the entropy is increasing. In this case, I have two options. Is the temperature high increasing ولا temperature low? لو temperature high, it's not favored. Sorry. I will write it as positive and negative. The delta G is positive. I'm sorry. The delta G is positive and delta G here is negative. Means that if the temperature is low, the reaction will not happen. And if the temperature is high, the reaction will happen. Oh, let me see. What was the case for us here? Do you remember what was the case for us when we have 25? What was delta H? It was negative or positive? In our example, what was the delta H? It was negative. The delta H was negative. So this one, the delta H is negative. And what was the delta S, yeah, mister? Delta S was T multiplied by S, which is 298 multiplied by the S. So it was also positive value. يبقى يا مستر لما يكون عندك نيجاتيف وبوزيتيف هتحصل مهما حصل. بوزيتيف ونيجاتيف will never happen. بوزيتيف وبوزيتيف بتحصل بس عند الهاي تمبريتشر. طب لو كانت اكزو والانتروبي decreasing هتحصل بس لما يكون at low temperature. المثال بتاعي كان بيقول ايه؟ دايما عند اللو تمبريتشر بس. دايما عند اللو تمبريتشر بس. بص كده المثال بتاعي كان عندي الدلتا اتش نيجاتيف والدلتا اس نيجاتيف، صح؟ بص كده. What was the example for me? Delta H was negative. Delta S was what? Negative also, because when you multiply this one by this one, negative. When the temperature is low, يعني 25 and less, it turned out to be what? Favorable. أمال لما temperature زادت, when it becomes 32, 33, 34, 35, it becomes unfavored. يبقى المثال بتاعي, my example was here. My example was here. The problem I just solved, sorry, the problem I just solved was here. يعني انت مستر لازم تجي لك دي. لا, it can be any case because it was at low temperature. When it was 20, 32 or less, it was okay, favored. But when you try to increase the temperature more than 32, what happened? It become what?
Unfavored.
Unfavored, because the delta H was negative and delta S was negative. So what I have to do, mister, I have to memorize it 100%, because he will tell me endo and entropy decreasing, positive and positive, I will tell him it will be only favored at low. طب positive and negative, it will never happen. It is going never to happen. ليه, mister? Because whatever you did, the delta G will be positive. طب if it is negative and positive, then it's going to be always favored. Why? Because whatever you do, high temperature, low temperature, delta G is equal to negative. ازاي يا mister? Let me try. Delta G is equal to negative and delta S is positive. So let's put any numbers. Negative 100, negative delta G is equal to negative 100 and positive delta S. So negative and positive, what do you get? Minus positive, so negative minus positive TS.
Negative.
So it's equal to negative. So whatever you do, then the result will become as negative at the end. Again, for the last time, I will say it has to be memorized 100%. He will ask me about it. So this is the different cases, and I need to know also how to apply them the same we did here. I need to understand what does this mean. Like in the problem that we have just solved it, 32 and more at high temperature is unfavored, but less than 32, it was okay.
Mister, can you send me the document of questions you have?
Yes, yes. The one we are answering from?
Yeah.
Okay, this is from the Princeton book. This is from the Princeton book, so I'll just send it also to you. Okay.
Okay, and if you have past sample exams from chapter 3 to 18 for the exam, send it to me.
Okay, okay. From chapter 3 to 18, okay.
Yes,
So,
please.
no problem. Delta G and phase changes. What is the delta G and phase changes, mister? This is another one which is very common, and phase changes. Mister, let's remember the heating curve together when you are making heating. So the solid starts to, this is solid, it starts to melt, and at the melting point, there is solid and liquid together, and then it becomes only liquid. And then you heat again. At the boiling point, there is, for example, if this is water, there is liquid and solid and gas together, and then you become gas only. So what is the relation between this one and delta G? At delta G is equal to 0, at a certain temperature, there will be equilibrium. So nothing is favored. Nothing is favored. What does it mean nothing is favored? If I have water and I am at temperature 100 degrees centigrade, or anything more than 100, what is favored? What is favored? The water will boil or the water will condense? The water will boil. Is it possible that you put the water at a temperature more than 100 and it doesn't boil, it condenses? No. So this means that if the water is at 100 degrees, any temperature more than 100, 101, 100, 203, the water starts to boil. So boiling becomes favored, right? What if it is trying to condense? This is unfavorable. It's not going to happen. It's not going to happen. What about the temperature 100 exactly? What is there at 100 exactly? This is at equilibrium. What does it mean, equilibrium? The delta G is what? 0, right? We agreed that at equilibrium, what is delta G? Delta G is equal to 0. What about more than 100? What is delta G? Negative or positive? I'm boiling water and the temperature is more than 100. It's what?
Positive.
But positive means it's favored or unfavored?
Unfavored.
But we said that anything more than 100, it will automatically boil or no? It will automatically boil. So it is delta G is equal to negative.
Negative.
There is no chance that you go and boil some water on the stove and raise the temperature to 150, and then you leave it after some while, and you go and ask yourself, okay, I'm not sure, I put it at 150, did it boil or did it condense? There is no chance. You are always 100% sure that it is going to boil, because you know that more than 100, the boiling is favorable. But is there any chance that it will condense? No, there is no chance it will condense. Because what? Because this is unfavorable reaction. But what happens if you did the opposite? What happens if you decrease the temperature? You move to the right or to the left? If you decrease the temperature, you move to the left. Is it going to condense or boil? Which will be more favorable if you decrease the temperature? If you decrease the temperature less than 100, what do you think? Which one will be more favorable? Mister, if you decrease the temperature,
it will become unfavorable.
Which one will become more favorable to happen?
Condensing.
Condensing, exactly. So if you move any temperature less than 100, then the condensation will be favorable and the boiling will be unfavorable. What about at delta G is equal to 0? What about at 100? No, this is an equilibrium. No one is favorable more than the other. So at 100, it is what? At equilibrium. So at 100, it is at equilibrium. Means this one is not favored and this one is not favored. That's why when you look at 100 degree, what do you see here? Liquid or gas or both of them? You see both of them. Why? Because no one of them is favored. طب Mr. how I'm gonna make use of this one? I'm gonna make use of this one in this way. He will give me a question and tell me delta G is equal to, can we try to remember the equation? Delta H minus T multiplied by delta S, correct? And then tells me what is the boiling point. What is the boiling point? How do I know the boiling point? He will give me delta G, so this is given. No, he will not give me this one. He will give me this one, given. This one is given. This one is unknown. And he will ask me, what is the temperature? What is the boiling point? How do I find it out? Mister, I have the delta H is given, for example, minus 100. And I don't know the T. And the delta S is, for example, 200. For example, right? Then what is T? Mister, I have two unknowns. I have delta G. No, delta G, it's not unknown. It's known. Mister, what is the boiling point? At boiling point, what is the delta G? At boiling point, what is delta G?
0.
So bravo.
0 Kelvin.
So what? What did you
Is
say?
it not 0 Kelvin?
It will be 0. It will be 0. 0 delta G. So I can now find the T. Now I have two unknowns again. I have one unknown only. So what is the boiling point? I need to find T, but I don't know delta G. But Mister, you are asking me boiling point. And at boiling point, it is a point of equilibrium. It's neither boiling or condensing. And you told me when you have delta G is equal to 0, then it is at boiling point. So I will remove this one and put 0. Now how many unknowns I have? Just one. Can I find this one? Yes. So let's try to find an example. Let's try to find an example. I have acetone, which is CH3, COCH3. Is this the acetone that I use to remove the finger nail polish? Yes, it is the same one. This is a ketone. So, Mister, it is at room temperature liquid. So, at room temperature, it is liquid. What does it mean? Yani at 25 degrees, it is liquid. And delta H of vaporization. What's the delta H of vaporization? Changing from what to what? From liquid to gas. So delta H is equal to 29.1 kilojoule per mole. And what's delta S of vaporization? 88.4 joule. Huh? Can I leave it as joule or I need to change it? You must change it to divided by 1000. Divided by 1000, what it will be? 0.0 and then 884. 884. So I change it, it becomes joule also. It becomes kilojoule also. What is the equation again? Delta G equal to delta H minus T multiplied by delta S. Mister, what is the boiling point? What is the boiling point? So delta G is equal to what? The same one we answered now. What? Since you are asking about boiling point, so delta G is equal to 0. And what's delta H? 29.1 here. And what's the temperature required to find? And what's delta S? 0.0884. Don't forget, 5 out of every 10 students forget to convert and then get the number wrong. So don't forget to convert the joule into kilojoule. So 0.0884. Then I will put this one on the other side. So 29.1 equal to this one, put it on the other side. So T multiplied by 0.0884. Then T is equal to what? 29.1 divided by, put this one down, 0.0884. If I solve, I will get T is equal to 329. What will be the unit? Kelvin or Celsius? Don't forget, it will be Kelvin. So 329 is Kelvin. So that's the boiling point. That's the boiling point he asked it for. And by the way, it's equal to what? It's equal to what in Celsius?
56.
56?
Mr. Is it minus 273 or
Yes.
298?
273.
Yeah, then it will be 56.
56 degrees. So 56 is the boiling point. Anything more than that is gas or liquid? Evaporated, so it will be gas. And anything less than 56 will be liquid. That's why he said at room temperature it is what? At 25 it is what? Liquid. So my answer is correct, sir. My answer is correct because 25 is less than 56 and you told me anything less than 56 is liquid. And he said at room temperature it is liquid. Okay, let's try to apply our rule. What is delta H here? It's negative or positive? It's positive, sir. Here. And what's delta S?
Yeah, so unfavorable.
And this reaction is this reaction is delta S is what?
Positive.
Is positive.
Positive.
And we said what happens when they are both positive? It will be favorable when?
At high temperature.
At high temperature only, mister. At high temperature only. So anything more than 56, this reaction is going to happen. It's going to boil. But at low temperature, what happens? It becomes what?
Not favorable.
Not favorable. So it's never going to boil. It's never going to boil less than 56. It's going to condense. Okay? So this proves that our rule is correct. At delta H positive and delta S is positive, it's only favorable at high temperatures only. At which higher than what exactly, mister? Higher than 56. This is the point at which delta G is equal to what? Is equal to 0. And anything more than that, the delta G is equal to become negative. And anything which is less than that, delta G is going to become positive. So anything here, it will become negative, and anything will become positive. If you want, you can even try. So you can even say that delta G is equal to what? Delta H minus T multiplied by delta S. Make any temperature which is less than 56. Let's say 25. So 298 multiplied by 0.0884. Can you try to put this on the calculator? Tell me what's it equal to? 29.1. And tell me what will be the delta G. We have chosen it to be 25 degrees. Why, Mr. You are doing? He didn't ask me for that, by the way. I'm just making sure that when the temperature decreases too much, less than 56, it becomes 298.
We get 2.7568.
2.7568.
2.7568. Yeah.
Let me try to do it again. 29 point, don't forget this one multiplied by this one. 29.1 minus all of that. Can we redo?
Yeah, I got the same.
Okay.
Same answer.
Yeah, this is the right one only, right? And then 29 point. So we have chosen delta G is equal to delta H, which is 29.1, and this is 88.4, which you said 0.0884, and this is 298, right? 273 plus 298. This is 29.1 minus 26.3432. So this is positive value. This means that the value become 29.1 minus 26.3. So I got, خلينا أجرب تاني. 29.1 minus 26.3432. Yes, 2 يعني طلعت 2.7568 صح؟ This is what you get at the
Yes.
end. So this is a
Yeah.
what? It's a positive value or a negative value?
Positive.
Positive value means the reaction is unfavored. So this proves that we are correct. Anything which is less than 56 is unfavored. It will be only favored at high temperature. Higher than what exactly? Than 56. Okay. And okay, I know that we have passed, but let's try to answer write this last equation. There is sometimes that he asks me to find a link between the equilibrium constant of the reaction, the equilibrium constant of the reaction, that's delta G is equal to minus RT multiplied by the ln of K. So this R is a constant value and is equal to 8.31. This is the constant for the gas constant, 8.31 joule per mole Kelvin minus 1. And I'm sorry, joule per mole multiplied by Kelvin. And the temperature is the absolute temperature in Kelvin. And the K is the constant of equilibrium. What is the constant of equilibrium? The constant of equilibrium is the same that we used to find out A plus B give me C plus D. K equilibrium is equal to the concentration of C multiplied by the concentration of D, everyone to the power of their coefficient, and the concentration of A multiplied by concentration of B, everyone to the power of their coefficient. For example, if this is 1, this is 2, this is 3. So 3 to the power of 3, C to the power of 3, and 1 to the A to the power of 2, and B to the power of 2 and 1 here. This is how we find it out K. So if you have the K, the equilibrium constant, getting the ln of it, you can, and we have the temperature, you can find the delta G and find if this reaction is happening in a way that's favorable or no. And if you have the K, you can also find the delta G. And if you have the delta G, you can find the equilibrium constant. And we have also some examples on that. And the last thing will be the relationship between, we'll give answers, questions about this one. The last thing is the relation between the reduction potentials and the delta G. One of the most famous things that we used to remember when we were doing the electrochemistry is when the reactions are favored, because sometimes, we will take this in electrochemistry again, sometimes when you put two metals in their solutions and connect them with a salt bridge and put a voltmeter here, the reaction occurs and the current flows. And sometimes when you put two metals, the reaction does not happen. The reaction does not happen, and it's unfavorable. And we used to say this is spontaneous, and this is non-spontaneous, if you remember. And this is non-spontaneous. Usually, when the reaction is spontaneous, this means that I have an E node value. Just remember, the value will be positive number. So the value will be a positive number. And if I have a non-spontaneous reaction, the E node will be a negative value. So, these two ideas have to go together in the same way. What does it mean? Yani if you put two metals, for example, you put copper and you put a more reactive one like zinc with it, and this one starts oxidizing, so loses electrons, current will move, electrons move like that, and electrons will move like that, and current will move like that. So it's favorable. Sometimes when you put two metals, like you put copper and copper together, or you reverse the cell, you don't get a reaction, because these two, there is no difference in electrode potential, so you don't get a result. There is no current here. And this happens because the delta E is negative. How we used to find this? We will remember this in the electrochemistry. But in order for this one to be spontaneous electrochemically, it has to also be spontaneous regarding the delta G. So if it is positive, it means that it's spontaneous. So the delta G also must be negative here. And if it is non-spontaneous, the reaction does not happen and the current does not happen, this means that the delta G is what? Is positive. Because we said positive means non-spontaneous and negative means spontaneous. And also vice versa. So if the reaction is favorable, forward, so the backward will be non-favorable. So if you try to make a reaction between zinc and copper ions, what will happen is that the zinc will be oxidized and the copper is reduced. The copper is reduced. So this one changes from solid into aqueous, losing electrons, and this changes from aqueous to solid by gaining electrons. And this reaction causes a delta E, an E node, which is positive. So this means that the reaction is going to happen and there will be a current. So the delta G must be what? Negative. If you try to do the opposite, if you try to put the copper and zinc, where the copper is the copper metal and zinc is ions, this is not going to happen. So zinc plus copper 2 plus. We know for two reasons it's not going to happen, because E node here will be negative and delta G is going to be positive. And we know that the copper cannot displace the zinc because copper is less reactive. When we come to the electrochemistry, we will be able to do this with more explanation, and we will be also getting more examples to relating these two chapters to each other.
Okay, Mr.